Hello everyone! Within the section Basic Concepts of Classical VA, Block 1 of Cost Engineering Training course, we will consider the concepts of a component of an object of analysis, as well as structural and functional models. The role of structural and functional models is to set the degree of abstraction of consideration of the conditional design structure, or list of functional carriers, FC, of the components and the complex of its inherent functions. The formation of a structural model, as a rule, is carried out to the basis of design documentation, taking into account the requirements for the output data of the analysis, i.e., taking into account the information needs of the customer of the analysis. In contrast to the structural model of the component, the main purpose of the functional model is a complete or abstract description of the functions of object of analysis, in accordance with the degree of abstraction of design structure specified during the formation of structural model, as well as the formalization of the relative importance of the functions of the component and the carriers of functions of which it consists. The direct executors of the work of formation of structural and functional models can be both specialists of the design engineering department, subject to requests from cost engineers, and they have sufficient qualifications, and cost engineers of first and second or third types themselves, if they have access to necessary technical and economic information about the object of analysis. As part of the discussion of today's topic, the following keywords will be used. I recommend the viewers of our channel to familiarize themselves with these keywords before watching this video. The term degree of abstraction, given on the slide, is among other things mentioned in the DIN 2803 Part 1 standard, Analysis and Formulation of Functions in Value Analysis, Basics and Methods. Before describing the method of decomposition of a component into a set of function carriers and the method of formulating the functions of a component, it's necessary to understand in the first approximation not only the meaning of such basic concepts of value analysis as structural model and functional model, but also the concept directly related to them: component, degree of abstraction of consideration of component, DACC, function, and function carrier. A more detailed review of the structural and functional models of components of various degrees of abstraction, as well as examples of their formation, will be devoted to the video of Block 1 entitled Structural and Functional Models, Classification, Examples. Component. This is the designation of the object of analysis used in the framework of the value analysis. The term component, being a symbol, can display the object of analysis in accordance with a given degree of abstraction depending on the objectives of the analysis. In practice, various variants of special classification of component can be used, which can be used in the value analysis process aimed at indicating the degree of abstraction. For example, design, marketing, economic, technological, etc. On the next slide, devote the degrees of abstraction of the component. The most commonly used degrees of abstraction of a component in applied cost engineering and examples of individual special classification are given. Degree of abstraction of component consideration, or DAAC. This is degree of compliance of the model of the component, object of analysis, with theoretical or real consumer market physical, chemical, technological and other properties of the object of analysis. The degree of abstraction of consideration is set by the subject of analysis, usually is cost engineer, in the process of forming structural and the functional models of the object of analysis, depending on the objectives of the analysis. The degree of abstraction of consideration may also depend either on the scientific field which the analysis is carried out, if we are talking about theoretical research, or in the industry, if we are talking about the analysis of real physical objects. The degree of abstraction, complete or abstract, of functional model is determined by the degree of abstraction of structural model, on the basis of which it's formed. Decomposition. This is a conditional representation of a component, an object of analysis, in the form of a model of a set of function carriers. The decomposition of the component can be performed both on the basis of the design stuff, on the basis of other principles of classification of the functions carriers due to objective of analysis. The definitions, functions, and classification of functions given on the slides, coupled with these three definitions given above, are without exaggeration of defining concepts of value analysis theory, along with the concepts of value analysis models, which will be outlined below. Here is the definitions of functional composition of a component product. FCC or FCP, function carrier, it's a key definition for value analysis, and design engineering composition or DEC. There are some definitions that we're already talking about, that defining concepts of value analysis theory in our training course. Taking into account the above concept, we introduce the concepts of structural model and a functional model. A structural model is an information model graphically formalized in the form of a table or other form, that purpose of which is to display the design engineering composition of the component and set the degree of abstraction of the component in consideration in the analysis process. When decomposing a component within the framework of a formation of structural model, there are a number of nuances that will be discussed below. A structural model of a component that fully corresponds to the design composition is called a complete structural model. Other variants of structural model that allow for certain simplification, deviations from the design composition, are called abstract structural models. A functional model is an information model graphically formalized in the form of a table or other form, the purpose of which is to describe the functional composition of a component in accordance with the chosen degree of abstraction of consideration given when forming the structural model of the component. A functional model of a component that fully corresponds to the functional composition is called complete functional model. Other variants of the functional models that allow for certain simplifications, deviations from the functional composition, are called abstract functional models. In the context of considering the concept of structural model and functional model, let's consider a general list of models that a cost engineer operates in practice, or a system of working models of a cost engineer. The system of working models of a cost engineer is a set of models of various types that cost engineer uses in practice. Respectively, cost engineers of types 1, 2, and 3 use a different list of models. I believe that the course participants are more or less familiar with the concept of model and the most common varieties of existing models. As part of the cost engineering course, we will move away from the most general definition of the model, describing the model as a system, the analysis of which serves as a means to obtain information about the modeling object, and we will use the following narrow formulation. Cost engineering models include a set of numerical, tabular, formally logical models of information, text, and etc., and intermediate sketches, drawings, 3D models, strength models, and reports, graphs, etc. To date, the boundary between mathematical, numerical, and intermediate models is blurred, since drawings, 3D models, and strength models are actually intermediate and mathematical numerical models. Since they are stored electronically in PDM database of the developer system. Nevertheless, the proposed division allows with some degree of abstraction to cover the entire list of models used cost engineer in practice. More clearly, the working models of cost engineer are presented in the table on the slide. Based on the table presented on the slide, among other things, it's possible to draw conclusions about the list of individual competences required by the cost engineer, about the main groups of specialists with whom the cost engineer interacts in the course of his activities. In particular, the necessary competences may include the ability to analyze and form models listed to the model name column. In more detail, the issues of the list of competences required by a cost engineer will be discussed in the video Cost Engineering Organization Unit Concept in Block 3 of our training course. The decomposition of a component into function carriers performed in the process of forming a structural model is performed not only taking into account a given degree of abstraction of consideration, but also taking into account individual application rules formed on the basis of practical experience. Such rules are not universal and can be formed depending on the industry, specialization of the design department, and other factors. We will consider the method of conditional volumetric carriers of function, CVCF, developed and used in practice by the author of this course. Thus, we narrow the scope of consideration of examples to limits of the machine building industry and its sub-branch general mechanical engineering, since the author has worked as a designer and cost engineer in the aviation industry, automotive and railway industry. We should immediately note that the applicability of the approaches under consideration based on the analysis of Lord's circuit in the structure of component as outlined will be limited, and for example, for the electronics industry, most of methods used require modification. For clarity of the presentation of information, we will consider typical components of consumer goods, namely a bolt with an internal hexagon and a housing of the front wheel of a mountain bike. In the next video of Block 1, titled Structural and Functional Models, Classification Examples, devoted to the consideration of examples of the formation of structural and functional models, we will be able to see that even these simple and at first glance components can be quite complex and time-consuming from the point of view of value analysis in the case of building structural and functional models. So, let's move on the methods of decomposition of a component into carriers of function as part of a structural model. The slide presents basic methods of decomposition in cost engineering. The methods of full and partial compliance with the design composition we will not consider in detail, noting only that they do not fully correspond to the etymology of their name, i.e., if the structural model fully corresponds to the design engineering structure of the object of analysis, design composition set out in the design specification, then even in this case it cannot be assumed that the decomposition is performed by the method of full compliance, i.e., with such an approach we will not necessarily get a complete structural model, CSM. The explanation of this fact will logically follow from the concept of conditional volumetric carriers of functions, CVCF, which we will consider below. Accordingly to the complete structural model will not be obtained if the decomposition method of incomplete matching was used, which is obvious. Generally speaking, I personally rarely use these two methods in practice, preferring the method of conditional volumetric function carriers, CVCF, as the most flexible from the point of view of decomposition. Let's consider the method of conditional volumetric carriers in more detail. When decomposing apart the case of full structural model and functional model, the component can be divided into conditional volumetric carriers of function. The etymology of this designation will be disclosed below. Involved in the transfer of loads inside the component's structure, i.e., the decomposition is performed based on conditional roots on the transfer of loads inside the structure, and the formulation of this name of the carriers the functions can be performed as follows, using the example the bolt and the housing of front wheel bushing of mountain bike. The bolt shape formed by these methods includes bolt head, key seat, shank, thread, protective coating, zombies tolerance, factory marking. Housing of the front wheel bushing includes cylindrical part, flange blend, constructive, non-technological, spoke flange, spoke head hole, brake disc rotor, flange, brake disc mounting hole, thread of mounting holes of brake disc, bearing seat, Donless tolerance for pressing the bearing, adapter seat, cataphoresis priming, paint coating, factory marking, and adverse encryptions. i.e., if we add up the conditional physical volumes of all the listed elements, then we should get the physical volume of the entire part. Then is the reason for the name of method is the designation volumetric carriers of functions. Appendix 1. The rule of avoiding surfaces. In order to prevent incorrect wording of the names of function carriers, the rule of avoiding surfaces should be used, a brief formulation of which is given on the slide. All of the above elements exceptions, which are essentially surfaces, should also be separated into separate structure elements of structural model, carriers of functions, function carriers, and included in the structural model. Appendix 2. The rule of standard technological elements. The purpose of applying the rule of standard technological elements is to exclude from the structural and functional models the maximum number of function carriers, the presence of which is the design of the component does not depend on the design and engineer, and it's due to manufacturing technology. The specified functions carriers include carriers that do not have direct functional purpose except for technological. This rule applies more to complete structural models, and as in abstract models, it's necessary to make a separate reservation about the place of standard products in the structural model of an average degree of abstraction, i.e., a model in which fasteners are taken into account but not in detail. i.e., for example, it's presented as a single function carrier called fasteners or other. A common mistake is overestimate the level or significance of these function carriers when forming a functional model, since fasteners, generally speaking, have a fairly large number of functions. As a rule, only one function is assigned to such an element of the structural model. And thus, in the abstract model, in this carrier of functions becomes at least significant. In some cases, fasteners are not included in structural or functional model. And in the structural model at all, on the basis that the cost of fasteners are not comparable with the cost of other carriers of the functions of the object of analysis. In addition to the above described technique of conditional volumetric carriers of functions, a subsection of technical specification devoted to the composition of the product can be used when forming the structural model. In accordance with the GOST 15.016/2016, this section of the technical specification is called product composition, but in practice it's often called composition and scope of delivery. In the process of applying the method of conditional volumetric carriers of functions, CVCF, for some objects of analysis, the classic questions arises: who stored on whom? For example, for such an element as a bolt, exclusion exceptions, the composition looks quite simple. Ball head, key seat, shank, freight, protective coating, zone with tolerance, factory marking. However, when formulating the placement functions, which will be discussed below, there is an understanding of the problematic nature of the question what is placed on what, a shank on a head or a head on a shank. There are a large number of such elements, both elementary, like a bolt, and more complex. This problem can be solved to some extent by formation of the main conditional in indivisible functions carrier or main function carrier by analogy with the concept of main function of the functional model. The peculiarity of the concept of main function carrier is that, unlike the concept of main function, it's a not of nominal concept and can be used in further calculations and in process of formation of reports of value analysis reports, i.e. the main carrier of functions can be introduced, including the 3D construction free models. Constructive tree, usually left on a screen, in which we have some elementary parts of 3D model. Thus, the main indivisible function carriers appears for the bolt in the form of shank with a head, i.e. their placement is not specified for these two elements. For the rest of the bolt elements, case seat, freight, protective coating, zone with tolerance, and factory marking, the placement is indicated based on the number of function carriers determined by the method of conditional volumetric function carriers, i.e. the freed function carrier will be placed on a shank function carrier and the key seat function carrier on the ball head function carrier. All functions related to load transfer introduced in the functional model, they are also assigned to the main functions carriers, formed from corresponding function carriers obtained by applying the method of conditional volumetric carriers of functions. The component housing, the approach is similar. The main function carrier in this case will consist of 5 lower level function carriers, as include cylindrical part, 2 flange blends, and 2 spoke flanges. Further, in accordance with the layout or placement method of function formulation, holes, seats, freights, etc. will already be placed or set or layout on the main function carrier. Such an approach to the formation of a list of load transfer functions, among other things, allows you not to delve into the power scheme of main function carrier, which generally speaking is more related to the area of responsibility of designers and specialists in the fields of strength, and rarely contains a significant potential for reducing the cost of the object of analysis. In fact, the main function carrier is a combination of several carriers of function formed. The principles of combining several function carriers into one main carrier may be different. In the case of a bolt, the logic is relatively transparent. There are no bolt shanks without the head. We do not take the studs into account and consider them a separate element. In the case of a front wheel bushing, there are also some clarities in the cylindrical part of the housing. The 2 spoke flanges and 2 flange blends are one part that's further machined for the mechanical formation of the remaining carriers of function. Thus, it's impossible to formulate a universal rule. It's necessary to consider each object of analysis separately. With regard to the objects of analysis of a high degree of abstraction, in particular the front wheel of a bicycle and the entire bicycle as a whole, there is no need to form the main carrier functions. With regard to the formation of abstract or incomplete structural and functional models, there are no strict rules for their formation characteristic of complete non-abstract models. As first approximation, it can be assumed that decomposition in the formation of an abstract structural model can be started using the rules of the formation of complete models, further simplifying, excluding or distributing individual carriers of function in favor of the most interesting carriers of function from the point of view of forming analytical reports. Based on the results of the analysis of the table's classification of general functions and classification of special functions presented on the slide, the following conclusions can be drawn. Conclusion number 1. In accordance with the terminology used in value analysis, technical specification is abstract model, since the wording presented in the sections of real technical specifications or technical specifications described in GOST 15.016/2016 is either universal for complete and abstract models, or is suitable only for abstract technical specification according to GOST. The degree of abstraction of technical specification depends on the stage of project implementation. The degree of abstraction decreases as the milestones of the project pass. The availability, conclusion number 2. The availability of a technical specification agreed by the parts for the product's component allows for the technical and economic analysis with a certain degree of error and calculations, but it's not a sufficient condition for the successful design for the component. Since the full list of component properties required for the development of the design documentation is contained only in the complete structural model. Thus, in order to develop working design documentation, in addition to the availability of technical specification, it's necessary to fulfill at least one of the following conditions. First, availability of complete structural and functional models of the component, assembly, unit, or part. Second, availability of design groundwork in the form of design documentation for similar products. We're talking here about analytics. Third, availability of qualified design staff, qualified design engineers with experience in designing similar components or products. The most favorable case from the point of view of managing the cost of the design components is the fulfillment of all three of the above conditions. Conclusion number 3. The abstract structural and functional models being formed have separate properties that distinguish them from the technical specifications, advanced analytical capabilities in terms of the technical and economic characteristics of the component. However, they are in some way a duplication of the design documentation, includes technical specification, drawings, 3D models, etc. The complete structural and functional models being formed in addition to the mentioned properties that distinguish them from the technical specification or another design documentation. They are unique in their own way on product that does not have an analog in the set of design documentation. When applied to full structural and functional models, scientific terminology, they have an obvious novelty, which consists in the qualitative addition of a set of a design documentation with its alternative form contains a basis for describing the technical and economic characteristics of component. The presence of consumer and technical and operational functions in the functional model, it's usually due to a given degree of abstraction, so consumer functions can be both in the full and the abstract functional model, whereas technical and operational functions are more likely to be present either in the full of the abstract model of low degrees of abstraction, i.e. as close to complete as possible, which will be the housing of Fromville Hub, which we'll consider in next issue devoted to practical cases of formation, structural and functional models. The presence of the functional model, a list of functions shown on the slide, classification of special functions, in addition to the degree of abstractions, but also on the purposes of the value analysis. Obviously, they will be presented either in full models or in models a low degree of abstraction. It's more likely that these functions related to the technical or production properties of the component, as well as the potential for its improvement, will be present in functional models used by designers or design engineers in the process of design engineering or improving the design of the component. The literature devoted to the value analysis and the university course of value analysis, as a rule, very superficially reflect the issues of the formulation of functions. In the starting course of cost engineering, this issue is considered in more detail, including due to the fact that today's issue will consider the rules of formulation functions that can be used in the formation of both abstract and complete functional models. Most of practical cases that I have met in the literature are abstract, even despite the insignificant complexity of the object under consideration. For example, such objects of analysis as glasses, scissors, standard fasteners, etc. Most authors, both domestic and foreign, consider abstractions to some extent, without bothering to expand the functional and structural model somewhat to make it suitable, including for design engineers. In our training course, we will try to correct this situation. In addition, one of the disadvantages of abstract models, which we will consider in future releases of the section of Block 1, is a low degree of reliability of analytical reports compared with reports generated on the basis of complete functional and structural models. So, in most cases, we can find the following general principles of function formulation in literature. The first, accuracy and brevity of the formulation, refers to the need to reflect the actual content of the process. It's desirable to formulate the function in two words, a verb and the third person of the present tense, and a noun must express the object to which the action is directed, stand in the accusative, singular or plural. Principle 2. Completeness of the formulation refers to the indication of the maximum number of functions performed by the carrier, including functions which is not intended. Principle 3. Binding to the formulation to specific function carrier refers to the need for an unambiguous indication of the carriers of functions is a functional model. And principle number 4, maximum unification of formulations, deals with the maximum unification of formulations. Let's consider the above general principles of function formulations in more detail. Principle 2, 3, and 4 are largely general, not only in name but also in actual content, i.e., guided by them, even if there is a classification of functions, it's quite difficult to formulate functions. We will not waste time on a more related detailed description of these principles, noting only that within the framework of the classification of functions and the methods of their formulation proposed in training course Cost Engineering, the fulfillment of these requirements is ensured. Firstly, by a detailed classification of functions. Secondly, by standard forms of tabular structural and functional model with correct filling of which is provided, binding functions to the appropriate medium. About principle number 1 should be discussed separately, since at a first glance it's most concrete of all the above principles is directly contradicts principles number 2 and number 3, since it does not allow for either the completeness of the definition or binding to specific function carriers. Let's consider this contradiction on the example of specific functions. For example, the layout or placement function refers to block 1, or block of general functions, consumer-based functions, having the wording to set case seat can be formulated by a verb and noun, i.e. corresponds to the formulation of principle number 1. Okay. At the same time, the function connecting the carriers of functions to each other and transferring loads refers to the main technical and operational functions. An example of the formulation of which may be perception of the shearing force acting on the ball. If it can be reduced to the option to perceive the shearing load or to perceive shear, nevertheless does not meet the requirements of principle number 1, because the noun it should denote the object to which its action is directed, i.e. the formulation has to be expanded again to the form to perceive the shearing load on SH or ball shank. It's code for ball shank. Let's consider a similar function to perceive bearing, in which the head of the volumetric carriers of the function can perceive bearing load at the point of force transfer to it and at the point of contact with the package. For example, ball head, so in this case a function formulated with the comment to perceive bearing load with comment bearing surface of HD, etc. Let us consider an example of the following aesthetic function to form a visual optical effects for facial surfaces, reflex, on, shadow, penumbra, light, glare, or and the next function to form the visual effect of the complexity of the component, the effect of many holes, many circles, many faces, etc. Or next formulation, to form the tactile effect of the front surfaces, the level of roughness, the presence of embossing, the effect of cold touch of the front surfaces. Generally speaking, it would be quite interesting to see how the listed aesthetic functions will be inscribed in the format of two words, and most importantly, who will understand later what exactly is described in the functional model, except for the person who has directly involved in this formation. In addition, if an object to which the impact is directed is introduced into these functions, see the general rules of functions formulation, then it's necessary to introduce a consumer, because the impact of essentially directed to him, and he is not being a carrier of functions, cannot be introduced. Such inconsistencies constantly arise in the practical value analysis. Therefore, the general rules of functions formulations should be taken solely as reference information, the adoption of which is desirable but not always possible. We come to the conclusion that the general rules of functions formulation given in the literature of the value analysis, as well as university course, are limited suitable for the formation of certain types of abstract models, and completely unsuitable for the formation of complex functional models used in functional cost design. Let's take a closer look at the list of functions used in the formation of complete and abstract functional model and the course of cost engineering. Formulation of the primary function. The formulation of a primary function ideally should cover all general function, which is subsequently introduced into functional models separately. The primary function is a nominal, and as a rule it's not used in the future in reports by results of value analysis anywhere except for the tabular functional model. The blocks of the remaining functions is a functional model are recommended to be formed in the sequence described below in the form of groups corresponding to the above classification of functions and combining functions both by their belonging by two blocks, general and special, and by their semantic content, semantic groups, since with this principle of grouping the number of missing or forgotten functions. All functions of the complete functional model can be grouped into the following conditional semantic groups. The block of general function includes a group of functions related to the ergonomic and tactile properties of function carriers, a group of functions related to the aesthetic and visual properties of function carriers, a group of functions related to the overall layout, physical placement, visual isolation, provision of seating, taking into account the restrictions of the placement of volumetric function carriers that are part of the main functions carrier, a group of functions related to mechanical, magnetic, and other types of connection of function carriers to each other and to the transfer of loads, perception of external load, transfer of loads inside the component, taking into account restrictions on the distribution of loads inside and outside of the main function carrier. A group of functions related to the formation of protective coatings, metallization, etc. A group of functions related to operational characteristics, manufacturability, placement of information plates, ergonomics, maintenance, etc. Factory marking stamps, technological elements of constructions, transportations, and storage, and etc. The next block of special function includes functions that do not carry consumer or operational value, do not affect the operability, reliability of the component or product, and the amount of costs for the life cycle. For example, function missing in the technical specification, identified during operation, and etc. kind of functions. The next, a function that reduce the efficiency of the primary functions of the component product. For example, weight, dimensions, presence or noise of other radiation, various types of environmental pollution, consumption of fuel, lubricants, and other consumables that do not carry consumer value. The next, functions, the introduction of which can be potentially increase the efficiency of the primary function of the component product by introducing new production technologies, meeting new customer operator requests. The formulation of functions is carried out in accordance with the general rules of function formulation, and the description of the function given on the slides, classification of general functions and classification of special functions. Below, we will consider in more detail the individual methods of function formulation used in the formation of complete and abstract functional models in the training course Cost Engineering. The list of methods considered separately is due to the fact that it's according to these methods that questions most often arise in the process of forming functional models. The first, formulation of function related to layout or physical placement. When formulating the layout or physical placement function, the placement of one function carrier on another is described, and the placement can also be considered to the formation of special seat. For example, feet of the mounting holes THBD can be placed on a brake disc rotor BDMH. Then the whole physical placement function to set BDMH is specified for the brake disc rotor BDF function carrier. The next, the freed physical placement to function sounds like to set THBD function is specified for BDMH function carrier. For the carrier of BDF functions, the freed placement function is not specified, since without the presence of BDMH function carrier, there is no question for the presence of the THBD function carrier. In addition, in this way, we avoid overestimating the BDF in the terms of number of placements. The layout of physical placement function is indicated in the function model in relation to protective coatings coming out to the front surface of applied to a large number of function carriers. The layout physical placement function is indicated for advertising labels and factory markings as part of the functional model only once one position line in the functional model, i.e. indicating one carrier function on which is directly applied. Usual limitations of the layout of physical placement function and the methods of conditional volumetric elements will be announced below. In relation to the concept of main function carrier, MFC introduced above the logic as follows. For function carriers includes the main function carrier, the placement function is not specified. For all other carriers of function that are placed on the main function carrier, these are usual holes, threads, seats, etc. The layout of the placement functions is indicated, i.e., for example, for the main function carrier housing. The functions can be formulated as follows: to set spore head hole, to set bearing seat, to set adapter, compensator seat, and etc. Next, formulation of functions related to the connection of function carriers among themselves and the transfer of loads. When formulating functions related to the transfer of loads, the method of forming the main functions carrier already described above can also be used. Thus, if this is not a main function carrier in the composition of the object of analysis, then the corresponding functions are formulated for each carrier of function. For example, perceive shear load on the function carrier, perceive bearing of the function carrier, perceive torsion of the function carrier, and etc. In the main function carrier is specified in the structural model of the object analysis, then all power functions or all load functions of the carrier of functions included in the main function carrier are assigned on the functional model to the main function carrier. Other functions carriers that are not included in main function carrier are assigned load transfer functions in the usual manner. With regard to the formulation of abstract functional model, the above classification of functions and the order of formation of block of general and special functions, as well as groups of functions within blocks, semantic groups, are not applicable in the above form. More precisely, its application does not have any effect, since it's incomplete and abstract models the classification of functions for the same component may vary significantly due to the different goals of forming abstract and complete functional models. As a first approximation, consumer functions, primary, base, and addition can be used to form abstract functional models. Further, the abstract functional model is refined in accordance with the task of analysis and may include various functions corresponding to the sections of the technical specifications for the analyzed product. In more detail, the relationship of the functional model formation process with the technical specification per component according to GOST 15/0/16-2016 will be discussed in the video of Block 2, Analogy of the Value Analysis Methodology and Technical Specification Formation Approaches. I suggest we end it for today. Put likes, subscribe, all bye.